Newton's law of gravity. So what is Newton's law of gravity? This law is essentially tells you how to calculate the force between two masses separated by a distance r. And that distance r, which I'll call big R here, is basically the distance between the center of masses. Okay, so the force is equal to this constant, we'll call it big G, times the product of the two masses over the distance squared. This is called an inverse square law, and we'll talk more about that later. So we need to discuss this coupling constant. I call it a coupling constant for gravity, big G. If you look at big G and solve for it doing the algebra on this equation, you'll see that big G is equal to a force times distance squared over kilograms squared. Kilograms times kilograms. So here are your units. And notice that the units of G, big G, it's a universal constant that is the same everywhere in the universe. Sometimes we call this Newton's universal law of gravity. It's equal to 1 Newton meter squared per kilogram squared. Now, you could also break that down into base units. These are honorary units, and the reason why they're called honorary units is because the Newton, the unit for force, is actually named after Newton. But we should know from the first semester that 1 Newton is equal to, you can remember that F is MA. So 1 Newton would be 1 kilogram meter per second squared. Therefore, we could also say that the units of big G are, it would be a meter cubed per kilogram second squared. I call these base units. Base units. Okay, now, so let's look at the general behavior of this law. So here's a nice little picture I got off the internet. And what we're going to do is we're going to change the mass and change the distance and see how that affects this law. So you can get an idea what's going on here. So here's our force law. Force is big G times M1 times M2 over R squared. What happens if you double one of the masses? Say the mass here becomes 2M. Well, that's just going to change your force by a factor of 2, because the only thing you're changing over here is you're letting M2 be 2M. What happens if you change one of the masses, if you triple one of the masses? Well, obviously your force would go up as 3 also, so that would be 3F. What happens if you double both of these masses? If you double both of those masses, you're going to have 2M times 2M would be 4M, so you see that would go up by a factor of 4. Now, what happens when we change the distance? Now, you got to be a little careful here. Let's look what happens. Let's start off with an intuitive case. If we double the distance r, you double that distance, and r becomes 2r, your force would go down by a factor of 4. So let's see how that happens. So let's call this F1. Okay, now let's say F2, and for F2, we say G we have G M1 M2 over R squared. Whoops, I've got to bring that up a little bit more. Okay, now, so let's see what happens here. So what we're going to do is, remember I said we're going to double R. So let's put parentheses here and double R. Make that 2R squared. See what happens? You have to square the change in R. So that becomes G times M1 times M2 over 4R squared. Just like that. So what happens when you double the distance, your force goes down by a factor of 4. And that should make sense to you, because essentially what you're saying is you increase the distance of separation, gravity gets weaker, right? And when you make this distance smaller, gravity gets stronger. So what happens if you half the distance between the two masses. If you half the distance between the two masses, then your force would go up by a factor of 4, because you've got to square the denominator, which would be 1/2 r squared. So that would be 1/4 r squared. The 4 comes back upstairs, and that would be 4f. So make sure you understand this, what's going on over here. See, over here, they're doubling the distance here, but they're increasing both masses by 2. So that's not going to change, because if you double each mass, that'll give you a product of 4 in the numerator. And if you double the distance, that'll give you a factor of 4 in the denominator. So that would be no change on F. Make sure you understand all these situations. Okay, that concludes this brief video.